Okay. Uh, then the fifth type of the electrode is the redox electrode. You know the redox is nothing but the oxidation reduction taking place simultaneously. It consists of an ion that is a metal like platinum in contact with the solution of metal ions in different oxidation state. Here you can see platinum is there. Then the ion Fe2 plus aqueous, Fe3 plus aqueous, cerium, that ceric 3 plus, Ce3 plus, and the Ce4 plus aqueous. Then the stannous Sn2 plus and the stannic Sn4 plus aqueous. Ferrous, ceric, ferrous, ferric. Okay, Fe2 plus is the ferrous, Fe3 plus is the ferric. Okay, Ce3 plus is the ferrous, Ce4 plus is the ceric. Sn2 plus is the stannous and Sn4 plus is the stannic. Means here ferric will convert into the ferrous, ceric will convert into ferrous, and the stannous will convert into the stannous. The reaction is there. Electrode reaction is noted there. You can see that Fe3 plus electron will give you Fe2 plus aqueous. Ce4 plus aqueous plus electron gives you the Ce3 plus aqueous. Sn4 plus electron gives you the Sn2 plus aqueous. Then you see this video.
What are different types of reversible electrodes? The reversible cells are having electrodes are known as reversible electrodes. The reversible electrodes are of following types. First is metal ion electrode. These electrodes are constructed by dipping any metal plate in its salt solution. It is the simplest type of electrode. In general, it is represented as metal is in contact with metal ions. When this electrode is in left hand side, that is oxidation takes place, the reaction is metal is converted into metal ions leaving number of electrons. This is oxidation reaction. For example, zinc is in contact with zinc ion solutions and the reaction is zinc gives Zn plus 2 ions plus 2 electrons. Copper is in contact with copper plus 2 ions in aqueous solution. So copper gives copper plus 2 ions plus 2 electrons. Aluminium is in contact with Al plus 3 ions in aqueous medium. So aluminium on reaction produces aluminum ions, aluminum plus 3 ions plus 3 electrons. Similarly, tin is in contact with tin plus 2 aqueous solution. So tin on reaction gives Sn plus 2 plus 2 electrons. In this case, the value of electrode potential depends on activity of the metal ion. So if the concentration of metal ions changes, the electrode potential will also change. Second, metal sparingly soluble salt electrode. In this case, the metal and its sparingly soluble salt is in contact with the electrolyte which contains same anion. For example, silver and silver chloride solid is in contact with chloride ions. The oxidation reaction for this electrode is silver combines with chloride ions producing silver chloride solid. This is the sparingly soluble salt plus giving an electron. Similarly, mercury and mercurous chloride solid, which is the sparingly soluble salt, is in contact with chloride ions. In this case, the oxidation reaction will be mercury reacts with the chloride ions producing half of the mercurous chloride solid plus electrons is liberated. Again, the potential value of this electrode also depends on the activity of the chloride ions, that means solutions. Third, gas electrode. There are several types of gas electrodes like hydrogen gas electrode, chlorine gas electrode, oxygen gas electrode. In case of hydrogen gas electrode, hydrogen gas is bubbled through hydrogen ion solutions, for example HCl. And for electrical contact, we insert platinum wire, which is the inert metal in electrochemistry. Hydrogen gas electrode on paper is written as platinum and hydrogen is in contact with H plus aqueous solution. For oxidation, the reaction is half of hydrogen is producing H plus ion and one electron is liberated. The potential of this electrode depends on the pressure of hydrogen gas and the activity of hydrogen ions. Fourth, metal insoluble oxide of metal electrodes. The electrode is obtained when metal and its insoluble oxide is in contact with OH- ions. For example, iron and iron oxide, which is insoluble salt, is in contact with OH- solutions. And the oxidation reaction for this electrode will be iron combines with two OH- ions, producing iron oxide, insoluble salt, plus water plus two electrons are liberated. Similarly, antimony and antimony oxides, when are in contact with OH- ions, they produce this type of electrode. So the reaction is 2 antimony combines with 3 OH- ions, producing half of antimony oxide plus 3 by 2 of water, and 3 electrons are liberated out. Similarly, manganese oxide and manganese dioxide can make a similar kind of electrode. It can be represented as platinum in contact with manganese oxide and manganese dioxide, which are in contact with aqueous solution of OH- ions. The oxidation reaction for this electrode is manganese oxide reacts with 2 OH- producing 2 manganese dioxide plus water, and 2 electrons are liberated. And the last one is the redox electrode. When two different oxidation state of same elements are present in the same solution, and if we insert a platinum wire for electrical contact, redox electrodes are formed. And potential developed across the platinum wire is known as redox electrode potential. For example, platinum is in contact with iron plus 2 and plus 3. So the oxidation reaction is iron plus 2 produces iron plus 3 plus 1 electron is liberated out. Similarly, tin can also produce a redox electrode. So the representation is platinum is in contact with tin plus 2 and tin plus 4 ions. And the oxidation reaction will be tin plus 2 produces tin plus 4 plus 2 electrons are liberated out. In this case, the electrode potential depends on the ratio of the activity of the ions in the oxidation and reduction state of the metal.